Have you ever really stopped to think about the physical magic that happens when you stream a movie? You know, the actual hardware that lets you watch something from a server that's thousands of miles away? Well, it's not just code, it's a whole system of dedicated gear. In this explainer, we're going to unpack the physical building blocks that make our entire digital world possible.
So, here's the plan. We're basically going to build a network from the ground up. We'll start with the absolute fundamentals, then we'll tackle those local connections with something called a switch, go global with routers, and finally, learn how to protect it all with firewalls. By the end, you'll see exactly how all these different pieces click together to create one seamless system.
All right, so before we can start talking about all this cool hardware, we've got to get on the same page about what we're actually building. So first things first, what is a network?
At its absolute core, a network is really just a system that lets nodes, and you can just think of a node as your computer or your phone, share resources. Now, that resource could be a file, it could be a printer, or, of course, an internet connection. This one simple idea is the foundation for, well, everything else we're about to build.
Okay, let's dive into our first problem. We need to create a small local network. We need a local connector, and that brings us to our very first piece of hardware, the switch.
So, just imagine this. You've got a handful of computers sitting in one office. You want them all to be able to share the same printer, or maybe access some files on a local server. How do you physically connect them all so they can actually, talk to each other?
The answer is this thing, a network switch. And honestly, the best way to think about it is like the internal mailroom for a single office building. It knows exactly how to take a message from one desk and deliver it to the correct desk, as long as that desk is inside the same building.
So, the most important thing to get here is that a switch only operates within one single local area network, or what we call a LAN. You can see it's packed with ports so you can plug all your local devices in, but, and this is the key takeaway, it cannot send a letter to a different building. It has no idea how to talk to the outside world, to the internet. And that leads us directly to our next problem, doesn't it? Our office is connected internally, which is awesome. But what if we need to connect to another office? Or what if we want to connect to the entire world? We're going to need a world connector. Yeah, this picture shows the switch's limitation perfectly. The New York office is all connected up, and so is the Tokyo office. But the switches in each place, they have absolutely no idea how to get a message from one to the other. They're basically two separate isolated islands. The solution to this problem? A router. And if the switch is the mailroom for one building, the router is like the city's central post office. Its whole job is to figure out how to get mail from your building to any other building anywhere in the world, sorting and directing traffic between all these different networks.
So a router's main gig is to provide connectivity between different networks. It's your gateway to the wider internet. And you might notice it has way fewer ports than a switch. And that's because its job isn't to connect dozens of individual PCs, but to connect entire networks to each other.
Okay, let's just lock this in, because this is probably the most critical distinction to understand. Switches connect devices within one single network. Routers connect different networks together. It's that simple. One handles local mail, the other one handles global mail.
All right, so we've connected our office locally, and we've connected it to the entire world. But with that global connection comes a brand new and very serious problem: danger. We're going to need a digital guardian. I mean, think about it for a second. The moment you connect to the internet, you've essentially opened a door from your private office network to, well, the entire planet. So how do you make sure that only the right people and only the right kind of data can come through that door?
Well, you hire a security guard. And in the world of networking, that security guard is called a firewall. It's a device that sits right at the border of your network, and its job is to inspect everything that tries to come in or go out.
Conceptually, what it does is pretty simple. It monitors all the traffic, both incoming and outgoing, and it checks that traffic against a set of security rules you've given it. If the traffic follows the rules, it gets through. If it doesn't, it gets blocked. And a firewall can be a dedicated piece of hardware like this, or it can just be a software application running on a machine.
So here on the left, you can see the firewall is letting legitimate, approved traffic pass right through between the two offices. No problem. But then on the right, as soon as a potential threat from an attacker shows up, the firewall checks its rules and immediately blocks that connection. Access denied.
Now, you're probably already familiar with the firewall that's on your own computer, right? That's what we call a host-based firewall. It's just a piece of software that's protecting that one single machine. The hardware we're talking about here is a network firewall, and its job is to act as a guardian for the entire network.
So, we have our local connector, the switch, we have our world connector, the router, and we have our digital guardian, the firewall. Now, let's see what a complete, functional, and secure network looks like when we put all these pieces together.
And here it is, the whole system working in harmony. You've got your local computers, and they're all plugging into a switch. That switch then plugs into a router to get access to the outside world. And, positioned right at the edge, the firewall inspects every bit of traffic that passes through that router, making sure the entire local network stays safe and secure.
So really, the big takeaway from all of this is that these three devices, switches for local connections, routers for global connections, and firewalls for security, are the fundamental physical building blocks that make our modern, interconnected world actually work.
Which of course leaves us with one last pretty fascinating question. We've seen the hardware, but how does it all communicate? What's the common language that lets a switch in Tokyo talk to a router in New York and make it all work? Well, that common language, that's a topic for a future explainer. If you found this breakdown useful, clicking that like and subscribe button is a huge help and lets us know we should keep making more of these. Thanks for watching.